In this module, I am going to talk about valence shell electron pair repulsion theory, which is otherwise called as VSEPR theory. This theory helps us to predict the shapes of covalent molecules. This theory was put forward by scientists Sidgwick and Powell in the year 1940 and further developed by Nyholm and Gillespie in the year 1957. Before we start predicting the shape of molecules, let's have a look at a few of the postulates of VSEPR. VSEPR says the shape of the molecule depends upon number of valence shell electron pairs around the central atom. I am taking the example of ammonia, where nitrogen is a central atom bonded to 3 hydrogen atoms. The pair of electrons involved in bonding are called as the bonded pairs of electrons, and the pair of electrons not involved in the bonding and localized on nitrogen is called as a lone pair. So VSEPR believes in determining the shape of the molecule based on the number of electron pairs. The second postulate says the pair of electrons in the valence shell they repel one another because the electron clouds are negatively charged. The third and the most important postulate of VSEPR is that the electron pairs tend to occupy position space that minimize repulsion and maximize distance between them. So whenever we try to predict the shape of molecules, you have to keep in mind the electron pairs should be present to minimize the repulsion and maximize the distance between them. Let's have a look at the shapes of few of the molecules. The first one being AB2, where A is a central atom bonded to 2 B atoms. I should place these B atoms around A such a way so as to minimize the repulsion and maximize the distance between them. When I arrange them, I got a linear shape. The shape of AB2 is linear. An example of AB2 is BeCl2, where beryllium has got 2 electrons bonded to 2 chlorine atoms. The second molecule we are going to look is AB3 kind, where A is a central atom bonded to 3 B atoms. I have to place these 3 B atoms around A to minimize repulsion, maximize the distance. When I do so, I am getting a trigonal planar. The shape of AB3 is trigonal planar. An example of AB3 is BF3, where boron has got 3 electrons bonded to 3 fluorine atoms. The next molecule I am going to discuss is the derivative of AB3, which is AB2L, where one of the bond pairs is replaced by a lone pair of electrons. We saw the shape of AB3 as trigonal planar, and in this, if I replace one of the bond pairs by a lone pair of electrons, the arrangement of electron pairs still is trigonal planar, but the shape has changed to bend shape. So the shape of AB2L is bend shape. Example of this is O3, where O is bonded to 2 oxygen atoms using a double bond and a single bond. To sum up, by VSEPR theory, let's see the shape of molecules. AB2 will take a linear shape, AB3 will take a trigonal planar shape, and AB2L will take a bend shape.